Hello, my name is Connor Tucker.
I'm Emilio Trujillo.
I'm James Soriano.
And I'm Jason Winke. We are Team 50 for Sunny D.
Hi, I'm James Soriano, and in today's presentation, we will go over our project, our work during the fall semester, the spring semester, roadblocks and constraints that have arisen due to current events, and our future work for the remainder of the semester. Project is a solar-powered desalination unit capable of providing at least 300 liters of water for agricultural use per day. And the unit will be designed, tested, and optimized here in Arizona, and then sent to Puerto Lobos, Mexico. And then an identical unit will be designed and built for use in a Native American reservation here in Arizona. So during our fall semester, we did the research and design phase for it. And so why solar desalination? Well, clean water is essential for human life and health. And even in today's modern world, an estimate of 11% of the world's population does not have regular access to clean water. A very clear solution could be desalination of seawater, as ocean water is very abundant across the globe. However, it is very energy intensive. So it'd be ideal if you could pair desalination with a sustainable energy source such as solar power. Our initial project scope was a personal sized solar powered desalination unit sustaining up to 4 people daily using seawater. Our target market back then was the outdoorsman, preppers, and people that like to sail boats and stuff like that. The unit would have used reverse osmosis technology to purify water at 1.5 gallons an hour using only 4 amps. However, halfway through the semester, when our found out the scope of our project, she had one that lined up with our goals and the technology we wanted to use. So this project was a solar-powered desalination unit, also using reverse osmosis, that operated at 800 to 1,000 psi. That was rated for 35,000 parts per million seawater and could run 24 hours a day using a 3-stage reverse osmosis membrane. And then our mentor was Dr. Christiana Hansberg. So accessing this existing system, the unit is located at Macro Technology Works, which is a few miles south of ASU's Tempe campus. And in order to work at Macro Technology Works, we had to complete a safety orientation and file paperwork for our access authorization. This took about 2 months due to the paperwork flow that had to be reviewed by each person. And we had to wait for an available orientation. So organizing the project was started by a previous senior design team and grad students. And once the project landed on us, most of the information regarding the desalination unit was disseminated through several different folders, people, and files on different computers. Team 50 made a Dropbox compiling all the relevant information on the solar powered desalination unit. That included parts, correspondence, design, schematics, and other relevant information. And after reviewing all the available documentation, we created a summary and a startup guide to troubleshoot the unit and get all the pumps working. Now I'm going to pass it off to Jason Wenke.
Thank you very much. So we're going to be reviewing the spring semester. So when the spring semester began, Team 50 began to actually put the system through intensive tests to make sure that it could work. And during these tests, we realized that there were a lot of issues with the system, such as leakage. So we were having a lot of leaks whenever we would run the high pressure pump, and a lot of mislabeled measuring devices, which were in some cases completely flipped around, and we had to switch those back. And a lot of these issues came from a lack of maintenance. So after we determined the points of failure, we moved on and we disassembled the entire unit and identified and reported which parts had broken. And with this list, we also made a list of regular maintenance parts. And so what these essentially entail is biological filters and other filters such as that either need yearly or monthly replacement. So after we'd made our list of broken parts, we went and contacted the manufacturers of the unit, and we said that we needed to order these parts, and they helped us make an account that completely stored all of our information. So we have submitted an order request to them, and we will, as soon as it gets approved by the budgeting team, hopefully we'll get them and we can resume testing. So this was the parts list that was completely broken, where we can actually now run the unit without fully replacing these. And this is just the budgeting for that. And this is a picture of the parts. So after we actually get budgeting approved, the replacement parts will only take 3 to 5 days to ship. This was, of course, an estimate before COVID-19 became serious in America. And after we receive the parts, we can literally begin testing the day that we install them. From the beginning point of testing, it should take only 2 to 3 weeks to be completely finished and know if the system is operational and optimized. So now I'm going to hand it over to Emilio Trujillo for roadblocks and constraints.
Hello. So when we first fired up the system to test it, we noticed that there was several leaks, as you can see in the picture to the right. It was leaking from the end caps in the reverse osmosis filter system, where there was confusion with the parts that were installed. Some were spec'd to have stainless steel, where ours were plastic. So we had to solve that and then go to order it. And we have asked to be able to store it indoors, because the fact that it was stored outdoors led to all the plastic piping becoming brittle and breaking and increasing leaks in other places. And then we're going to test it outdoors once we make the repairs. But since it was left outside, it didn't get the maintenance that it needed. And the budgeting team before COVID-19 happened were a little all over the place, and communication wasn't the best. It was a little hard to get a hold of people to order parts, though it is nice having not to worry about the budget with respects to the senior design project, as we have our own funding. Being able to reach these people to order parts has not been the easiest so far, and the fact that COVID-19 has happened has only made it more tough. And we've been in touch with our mentor and other professors working on the project, and we are going to move forward with ordering the parts. And we're going to order the parts, and then we would no longer be able to meet in person. We just got word today that there's a stay-at-home order issued by Governor Doug Ducey, and we will no longer be able to access the unit at the MTW building in the ASU Research Park, which will not allow us to get the tools necessary for the repair. We've been in contact with other people working on the project, and they said that ordering the parts aren't going to be the issue. We're going to be able to order them and receive them just fine. It's just we won't necessarily be able to get at the unit to repair it and test as far as the restrictions are in place. And the format for our deliverables have changed as everyone's switched to online, and some of our members are no longer even in the area as they've had to return home for family reasons and just because of the situation in general. It's affected, I think, more things than anyone could have ever anticipated, and we're going to be taking a new approach, continue moving forward with the project. I'm now going to hand it off to Connor Tucker for future work.
Yeah, hello, it's Connor Tucker, and I'm just going to discuss how we've decided to move forward with the project. First off, we really, what our original end goal was to get the unit functional and integrated with solar power. We wanted to repair and install basically all the parts that we've attempted to order and get it to run seamlessly so we could test and make sure it was a bit ready to be sent down to Mexico. We actually did have a planned meeting with the team from Mexico coming up here to check out the unit with us so that they'd be able to take it back. But again, that has fallen through and has been canceled due to COVID-19. Next slide, please. So we've decided to pivot to a design-based plan since the physical work and maintenance won't be able to be completed now. We will look into actually providing a more encompassing design plan. This includes revamping the process and controls diagram and electrical layout sheet, adding an instrumentation system that is electronic instead of the current just physical instrumentations. Basically allowing it for whoever picks up the project, and when research reopens, they would be able to implement all of the changes that we'd like to make, but easier and with a guide. Next slide, please. So really, all in all, roadblocks and issues happen. It is more important how you react to them and finding ways to continue taking steps forward with the constraints that they implement. And we feel that this design will still allow the research project to move forward even without our team. It will provide it'll provide a budget, it will provide a parts list and instructions on how to move it forward, how to connect it to solar, and how to implement the instrumentation system that we wanted. It should also allow us to present our project online for senior design a little bit easier, since our planned original deliverable was to have the physical unit there and running. And I think in times like these with natural disaster, it does become apparent that access to clean water is essential. If we didn't have our access to clean water that we're lucky to have in the United States, situations like this would be much worse. So I just wanted to say thank you. This is where we would take questions. If you want, please send us an email. We'd be glad to answer any questions. And thank you for watching our presentation.
Thank you.
Thank you.
Thank you.